Hi students, welcome back to our video class. This is yours S. Ramunayudu, School Assistant Mathematics, ZPHS Satvelli. Already we have posted some lessons about 10th class. This is our now we have introduced our new lesson about 10th class, linear equations in two variables. Clearly, the pair of linear equations in two variables. Now let us move. Today we can discuss about pair of linear equations in two variables. In that particular chapter, in pair of linear equations in two variables, now let us try to know about introduction of linear equations in class 10. First of all, before we enter into pair of linear equations in two variables, we just recall our 7th, 8th and 9th class linear equations. We have linear equations introduction in 7th class, and already we have learnt a linear equation in one variable in our 8th class, and a graph of linear equation in one variable represents a straight line. And also we have known the solution of a linear equation in one variable. Next, in our 9th class, we learned some advanced linear equation in two variables. What is a linear equation in two variables? And solution of linear equation in two variables, the graphical representation of linear equation in two variables, and if we have some data, some written data, some situation, then we have to write, we have to write a linear equation in two variables. For example, some Sachin and Sehwag together scored 190 runs in a test match. What are unknown quantities are there? Runs that scored of Sachin and runs that scored of Sehwag. These two are unknown quantities. For this, first we get into definition of a linear equation. In our particular case, linear equation, before we enter into linear equations, we know variables and constants. We know variables and constants. We know variables. What are variables and constant? Some x, y, a, b, c, like this. These are variables. And 1, 2, 3. These are constants. If we write an expression, by using variables, This is called an mathematical expression. Mathematical expression. In that particular mathematical expression, we have known uh, clearly. We know in a mathematical expression that is called as algebraic expression. We know the degree of a polynomial. If the degree of the polynomial is 1, this is known as a linear equation. In that particular linear equation, if we have one variable, that is called linear equation in one variable. Now we can move into linear equation in two variables. Here, if a linear equation has two variables, if a linear equation has two variables, then it is called a linear equation in two variables. If a linear equation has two variables, already we have known one variable and also two variables in our ninth class. If a linear equation means if the degree of a polynomial is 1, then that is a linear polynomial. If it is an equation, this is known as linear equation. In particular, now if that linear equation has two variables, then that is called linear equation in two variables. If it has one variable, this is known linear equation in one variable. Next, actually it is usually denoted by variables x and y. We just discussed. Variables means unknown quantities. Variable means unknown quantities. For example, the cost of 1 kilo tomato and 2 kilos potato would be 30 rupees. Here unknown quantities. 1 kilo of potatoes and 2 kilo of tomatoes together cost 30 rupees. What are unknown quantities here? Yes, 1 kilo of the cost of 1 kilo of potato and the cost of 1 kilo of tomato are unknown quantities. But for our writing simplification, we can use A, B, C, D and so on X, Y, Z are representation for X and Y. Here we clearly write it is usually denoted by variables X and Y. We denoted variables by X and Y. But just to be discussed now, we can use any English alphabet. As usually we can write small letters instead of variables. For example, here, observe here, 4x plus 2y is equals to 100. 4x plus 2y is equals to 100. In this particular case, observe this, 4 is a constant, x is a variable. Here, 2 is a constant, y is a variable. Here, 4x plus 2y is an expression. 4x plus 2y is equal to 100 is an equation. But the degree of this equation or degree of this expression is 1. So degree of this equation is 1. This is a linear equation. In this particular case, we have two variables. So it is the example for linear equation of two variables. Linear equation in two variables. 4x plus 2y is equals to 100. Guess, you can guess some more linear equations in two variables like x minus y is equal to 20, 2x plus 3y is equals to 50, x plus y is equal to 100, x is equal to y is equal to x by 2, whatever it may be. These are all called as linear equations in two variables. Now, just after your guess, we have to read p plus 3q is equals to 50. What are variables here? P and Q. variables in p plus 3q is equals to 50. Now let us move. 3u plus 2v is equals to 11. Like for example, 3 books plus 2 pens together cost 11 rupees. Or some 3 shirts plus 2 fans cost, stitching cost together 11 rupees or 1100 rupees, whatever it may be. Then 5s minus 2t is equals to 3. 5s. 5s means 5 times of s minus 2 times of t, where s and t are variables. S and t are variables. 3 is a constant. Again, 5x minus 7y is equals to 3. Ante that means if we put different values for x and y, we can give 3 or not 3. We can we can get the value 3 or not 3. If it satisfies, if it is equals to 3, that is the solution. Otherwise that is not solution. We can discuss that in next slide. All these are examples for all these are p plus 3q is equal to 50, 3 plus tv is equal to 11, 5s minus 2t is equal to 3, and 5x minus 7y is equal to 3, and so on, are examples of linear equations in two variables. Now let us discuss. For example, this p plus 3q is equals to 50. All students just observe. P plus 3q is equals to 50. In this p plus 3q is equal to 50, this is equals to 50 plus 50. If we move in this side, plus 50 is replaced by minus 50. So p plus 3q minus 50 is equals to 0. P plus 3q minus 50 is equals to 0. In generally we know ax plus by plus c is equals to 0 is the general form of linear equation in two variables. In our 9th class we have discussed about this. Then 3u plus 2b is equal to 11. This is plus 11. If we write this is as 3u plus 2b minus 11 is equals to 0. 3u plus 3u plus 2v minus 11 is equals to 0. Okay, where 3u plus 2v is equals to 3u plus 2v minus 11 is equals to 0. And just this is just I forget to write here 3u plus 2v. This is equal to 11. This is 3u plus 2v minus 11 is equals to 0. Next one, 5s minus 2t is equal to 3. This can be written as 5s minus 2t minus 3. This is plus 3. We replaced it by, if it move into LHS, it can be written as minus 3. Now let us move to next equation. 5x minus 7y is equals to 3. 5x minus 7y is equals to 3. In RHS we have plus 3. If we transport into left side, 5x minus 7y minus 3 is equal to 0. These are all general forms of linear equation. Again we repeat, if a linear equation has two variables, then it is called a linear equation in two variables. Now let us move into another slide. Next concept. General form of a linear equation in two variables. Already just we said ax plus by plus c is equal to 0. But there is some condition for represent a linear equation. What is the general form of a linear equation? Just observe. According to our previous examples, the general form of a linear equation the general form of a linear equation, in two variables xy is ax plus by plus c is equals to 0. Dear students, so observe here, where x and y only are variables, we treat x and y as variables and a, b, c are real numbers. Where a, b, c are real numbers. Where a, b, c are real numbers, x and y are variables, then the general form of a linear equation is ax plus by plus c is equals to 0. Ax plus by plus c is equal to 0. What is the condition for this? Ax plus by plus c is equal to 0 represents a linear equation. Both a and b are not simultaneously 0. That means both are not 0 at same time. Both are non-zeros at same time. Otherwise, we have another definition. Yes, in general, an equation of the form ax plus by plus c is equals to 0. An equation of the form ax plus by plus c is equal to 0, where a, b, c are real numbers, and where at least one of a or b is not 0. Already we discussed here, a, b are not simultaneously 0. That means if a is 0 but b must not be 0. If b is 0, a must not be 0. Then this is written as a square plus b square not equals to 0. This is the condition for. Dear students, this is very, very important. The condition for ax plus by plus c is equal to 0 represents a straight line or a linear equation is a square plus b square not equal to 0. A square plus b square not equal to 0. This is called a linear equation in two variables x and y. An equation in the form a plus b plus c is equal to 0, where a, b, c are real numbers and where at least one of a or b is not 0. That is, a square plus b square not equal to 0 is called a linear equation in two variables x and y. I think these students have you have understand this. Otherwise, just you can repeat this. Now, what is the solution of linear equation in two variables? Solution of linear equation in two variables. For example, if we have a linear equation x plus y is equals to 5. Just I write here a simple equation. For example, you take the value of x as 1, value of y as 1. 1 plus 1 is equals to, what is the value of 1 plus 1? This is 2. But here x plus y is equal to 5. But if we take x as 1, y as 1, the sum is 2. Is they are equal? No, they are not. Are they equal? No, they are not equal. So this is not solution. Some of you take, if the value of x is 1 and the value of y is 4, what is the sum of 1 and 4? Is nothing but 5. Is it satisfied? Yes. The value of x is 1 and if the value of y is 4, it satisfies the equation. Then it is the solution for x plus y is equal to 5. Then if you take x is equal to y is equal to 3, x is equal to 3, y is equal to 2, x is equal to 0, y is equal to 5, x is equal to 5, y is equal to 0, x is equal to 4, y is equal to 1. This is 1.5, this is 3.5, this is 0.5, this is 4.5. How many? How many solutions for a linear equation? Clearly we know x plus y is equal to 5 represents a straight line. So a straight line have infinitely many points on it. So each point of a straight line is solution of that equation. So a linear equation has infinitely many solutions. A linear equation has infinitely many solutions. Now let us see some more examples. Here, therefore, any pair of values of x and y which satisfies the linear equation in two variables is called its solution. Therefore, any pair of therefore any pair of linear equations, any pair of values x and y which satisfies the linear equation two variables is called its solution. Just we discussed. Any values of x and y which satisfies the linear equation two variables is called its solution. For our previous example, 4, 1, 2, 3, 3, 2, 1, 4, 1.5, 3.5, these are all solutions for that particular linear equation. Just observe here, 3x minus 2y is equal to 5. Just I'm trying to write a solution for this. If x is equal to 3 and y is equal to 2, if we substitute x by 3, 3 3 is 9, minus y by 2, 2 2 is 4, 9 minus 2 is equal to, sorry, 9 minus 4, 2 2 is 4, 9 minus 4 is equal to 5. So here both LHS and RHS are equal, so the x is equal to 3 and y is equal to 2 is solution of 3x minus 2y is equal to 5. This solution is written as an ordered pair 3 comma 2. Here this solution is written as 3 comma 2. This solution is written as 3 comma 2. How many solutions for this linear equation? Just we discussed now, this linear equation has infinitely many solutions. For example, suppose we take x is equal to 4. How can we solve? Just I recall our 9th class concept. If let x is equal to 4, what is the value of y? What is the solution? For 3x minus 2y is equal to 5. If we substitute x is equal to 4, 3 4s are 12. 12 minus 2y is equal to 5. 12 minus 2y is equals to 5. Now we have, which is an equation in one variable. We have an equation in one variable. For solving the meaning of solve this, we can find the value of y. Observe here, on solving, we get 12 minus 2y is equal to 5. For example, this is plus 2. We transpose it into RHS 5 minus 12. What is the value of 5 minus 12? Is equal to minus 7. Minus 2 is multiply here. If we transpose it, it divides. Otherwise, if we multiply this number both sides by minus 2, if we divide by minus 2, y is equal to minus 7 by minus 2, minus by minus into minus, plus the value of y is equal to 7 by 2. Now what is the solution? For here 4 and 7 by 2, here 4 comma 7 by 2, where the value of x is 4 and 7 by 2 is value of y. This is called as ordered pair. We can write the solutions in the form of ordered pair. Here this is x coordinate, this is y coordinate. Suppose, just dear students, you can write, do you find some more solutions for 3x minus 2 is equal to 5? After watching this video, you can try to find some more solutions on the basis of if you take any values of x and y, we can convert the equation into one variable, then we can find the value of other variable. We can get the final solution. Next, what is the meaning of just we discussed about pair of linear equation in two variables. Until now, we have discussed what is a linear equation of one variable, linear equation of two variables, solution of variables, general form of solution of linear equation in two variables, general form of linear equation in two variables. Now we discussed pair of linear equations in two variables. Pair means number two. Two things is nothing but known as pair. A pair of values of the variables x and y which together now just I give solution also. What is the solution Koda? I mean, what is the solution? A pair of values which a pair of the values x and y which together satisfies each one of the equation called a solution of pair of linear equations. Actually, we know solution for what values of x and y satisfies the linear equations, that is called a solution for linear equation. In particular pair, that solution must satisfy both values of both linear equations. Satisfy for values of x and y, it is the solution. What will be the number of solutions for a pair of linear equations in two variables? Then we have a doubt in our mind. How many solutions for a pair of linear equations? In our next session, we must know the number of solutions. What are the conditions for linear equations? Is the number of solutions infinite or unique or none? We can know the answer for this question in our next video or next session. Just I'm trying to say pair of linear equations in two variables a1x plus b1y plus c1 equal to 0, where condition a1 square plus b1 square not equal to 0 and a2x plus b2y plus c2 equal to 0. This is the condition a2 square plus b2 square not equal to 0 form a pair of linear equations in two variables a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Dear students, observe here x and y are variables. X and y are variables. A1, B1, C1, A2, B2, C2 are constants. Dear students, once again I repeat here. A1, B1, C1 are constants. X and y are variables. A2, B2, C2 are constants. X and y are variables. Now a1x plus b1y plus c1 is equal to 0, adx plus b2y plus c2 is equal to 0 is a pair of linear equations in two variables. This is also known as system of linear equations. Also we call it as system of linear equations. This is also known as system of linear equations. Now let us move into another concept. Expression as linear equation in two variables. How can we express? Already we know expression of a linear equation. If we have a situation, can we express as a linear of a linear equation, a system of linear equation? Suppose here Hama's age is 4 times the age of Mary. Hama and Mary are some two friends. Hama's age is our daughter and mother, whatever it may be. Hama's age is 4 times the age of Mary. Write a linear equation in two variables to represent this information. Hama says, dear students, first of all, we understand the question. If we understand the question very well, we have get the answer easily. Otherwise, we can't write answer. Hama's age is 4 times the age of Mary. Write a linear equation in two variables to represent this information. Dear students, first identify what are variables. Hama's age, Mary's age, Mary's age and Hama's age. These are variables. And that means what are unknown quantities? Ages of Hema and Mary. The age of Hema and that of Mary are unknown quantities. Now we can take already just uh, we have no we knew we take A B C X Y Z as for unknown quantities. Now let Hema says be X years and of Mary be Y years and that of Mary be Y years. Just we take the age of Hema is X years and and the age of Mary be Y years. If Mary age is Y, then Hema age is 4Y. Why? Because 4 times of Mary. 4 times of Mary. So, if Mary's age is Y years, for example, Mary's age is 10, Hema's age is 4 times of Mary, 40. If Hema's age is Mary's age is 5, Hema's age is 4 5s are 20. So, if Mary's age is Y, then Hema's age is 4Y. According to the given information, Hema's age is 4 times the age of Mary, X is equal to 4Y. If we transport plus 4Y moves into LHS, X minus 4Y is equal to 0. This is a linear equation in two variables. This is a linear equation in two variables. Dear students, understand this. This is a linear equation in two variables. Okay, students, I hope you all understand this. Let us move to another example. One day, let us move into another example. All of you read this question. One day, Siri went to a bookshop with her father and bought 3 notebooks and 2 pens. One day, Siri went to a bookshop with her father and bought 3 notebooks and 2 pens. Her father paid 80 rupees for them. 80 rupees for 3 notebooks and 2 pens. Her friend Lakshmi. Her friend Lakshmi liked the notebooks and pens. Suppose Siri take this school. Her friend Lakshmi liked these notebooks and pens. So she too bought 4 notebooks and 3 pens of the same kind for 110 rupees. Express above situation as pair of linear equation in two variables. Students, once again we repeat. One day Siri went to a bookshop with her father and bought 3 notebooks and 2 pens. Her father paid 80 rupees for them. Her friend Lakshmi liked the notebooks and pens. So she too bought 4 notebooks and 3 pens of the same kind for 110 rupees. Express the above situation as pair of linear equation in two variables. Observe what are unknown quantities here. With cost of one book and cost of one pen are variables are unknown quantities. Cost of one book and cost of one pen are unknown quantities are unknown values. These are taken as variables. Now for variables we can take X and Y. So we have two situations which can be represented as follows. Just let cost of one notebook be X rupees, cost of one notebook be X rupees, and the cost of one pen be Y rupees. Understand, students? Let cost of one notebook, this is unknown quantity, cost of one notebook, and the cost of one pen be Y rupees. First we try to write linear equations for series amount. I mean series spended amount. Siri paid 80 rupees for 3 notebooks and 2 pens. That means her father or C paid 80 rupees for 3 notebooks and 2 pens. That means the cost of 3 notebooks and 2 pens together 80 rupees. Total cost of 3 notebooks and 2 pens be 80 rupees. The cost of one pen, one notebook X. The cost of 3 notebooks, is 3x. The cost of one pen be y rupees. The cost of 2 pens be 2y. Total cost means 3x plus 2y. Observe here, 3x plus 2y is equals to 80 rupees. What is the total? 80. Understand? The cost of one notebook x, cost of 3 notebooks 3x, cost of one pen y, the cost of 2 pens 2y, the total cost 80. So 3x plus 2y is equals to 80. Now Lakshmi also bought the same types of notebooks and pens as Siri. Observe here, the notebooks and pens are same as Lakshmi and Siri, both are bought. So the cost of that notebook, one notebook be x rupees, the cost of one pen be y rupees. Also, Lakshmi paid 110 rupees. Lakshmi paid 110 rupees for 4 notebooks and 3 pens. Now, observe here, total cost of 4 notebooks and 3 pens be 110 rupees. Now, the cost of one notebook X, 4 notebooks be 4x rupees. The cost of one pen be y rupees. The cost of 3 pens be 3y rupees. So total cost 4x plus 3y. Total cost 4x plus 3y. But what is the total cost she spent? Means 110 rupees. 4x plus 3y is equal to 110 rupees. These two are linear equations in two variables for the given situation. Now we can move into another example. The perimeter of a rectangular plot is 32 meters. If the length is increased by 2 meters and the breadth is decreased by 1 meter, the area of the plot remains the same. Perimeter of a rectangular plot is 32 meters. Length is increased by 2 meters and the breadth is decreased by 1 meter. The area of the plot remains the same. Find the length and the breadth of the plot. Express the situation as pair of linear equation in two variables. In this situation, just we can write only linear equations. Now, just we take the length as L and the breadth as B. Length as L and breadth as B. Observe here, if the length is increased by 2 meters, old length L, this is L plus 2, and breadth is decreased by 1 meter. Decreased means reduced. B minus 1. Now, let just we discussed here, let the length of and breadth of rectangle plot be L and B respectively. Then the area of the rectangle is LB, length into breadth, and its perimeter is 32 meters. What is the formula for perimeter? 2 of L plus B is 32 meters. First, we can solve this. L plus B, this is into 2, it means divided by 2. 32 by 2 is equal to 16. If we express it as linear equation, L plus B plus 16 moves into LHS minus 16, L plus B minus 16. Understand? 2 of L plus B. L plus B, this is into 2. This, if it moves here, by 2. 32 by 2 means 32 by 2 is equals to 16. 32 by 2 is equals to 16. 32 by 2 is equals to 16. So L plus B minus 16 is equals to L plus B minus 16 is equal to 0. Now, when the length is increased by 2 meters, then new length is L plus 2. Also, breadth is decreased by 1 meter, so new breadth is B minus 1. Now, the area of then new area, length into breadth L plus 2 into B minus 1. Observe here, the area of the plot remains the same. So previous area is LB and the new area is L plus 2 into B minus 1. These both are equal. Since there is no changes in the area, L plus 2 into B minus 1 is equal to LB. L plus 2 into B minus 1 is L into B, LB plus into minus minus L into 1L plus 2 into B 2B plus into minus minus 2. If moves here LB minus LB, this minus L goes to here plus L plus 2B minus 2B minus 2 plus 2. LB cancel. L minus 2B plus 2 is equal to 0. This is another linear equation for this. For finding the measurements of both length and breadth, we can solve this in our next session. We can learn the solution of linear equations in two variables, the methods, what methods do we have for solve these consistent, inconsistent, dependent, and a graphical method we have discussed in next session. Thank you. This is yours, S. Ramunaidu, School Assistant, Mathematics. I hope you are all understand this video. Thank you for watching and all the best. Thank you, students.